Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 5 video from the chapter of surface areas and volumes, I will be solving the set 4 of 5 conceptual problems from the textbook of author R.D. Sharma. These problems are based on the surface areas and volumes of a right circular cylinder which are termed as RCC. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so these are all fill in the blanks problems. The first problem says the cost of painting the total outside surface of a closed cylinder at rupees 3 per centimeter square is rupees 2772. If the height of the cylinder is 2 times the radius, then its volume is. Okay. So since the total cost is given and we know the cost per centimeter square, we can find the total outside surface of the cylinder using unitary method. So total surface area TSA will be equal to the total cost rupees 2772 divided by cost per centimeter square rupees 3 per centimeter square. This will be 924. So this is 924 centimeter square. So the total surface area of the closed cylinder is 924 centimeter square. Okay. Now this is the total surface area. Now remember, for a cylinder, if the base radius is r and the height is h, what is the total surface area? Now total surface area means TSA is the area the curved surface LSA plus the area of the two end surfaces or the area of the two bases. TSA we know is equal to 2 pi r multiplied by r plus h. Now it is given that the height of the cylinder is 2 times the radius. So h is equal to twice r. So this is equal to 2 pi r r plus twice r, which is equal to 6 pi r square. So this implies we must have 6 pi r square should be equal to 924. From here we have to find r. Once we know r, we can also find h from using the fact that h is twice r. So this implies r square will be equal to 924 by 6 pi. Now for pi you will use for the value of pi you will use 22 by 7 by 6. This is 22 multiplied by 7. Okay, 32. So let's see. 22. Okay, I'm not calculating. I'm not doing manual calculation. I'm straight away using calculator to do all the mathematical calculation to save time. Divided by 22 is equal to divided by 6 is 49. So this is 49. 49. Obviously then r will be equal to square root of 49, which is equal to 7 centimeter. So this implies h will be equal to twice r, 2 into 7, 14 centimeter. So height is 14 centimeter and r is 7 centimeter. Then volume is, we know volume is pi r square h. In fact, okay, so pi r square h. So pi is 22 by 7 r square we know is 49 and h we know is 14. So this is equal to 7, let me see, 22 multiplied by 7, 22 multiplied by 7 multiplied by 14 is 2156. So 2156 centimeter cube is the volume of the cylinder, closed cylinder. Now, as I always say, if you have any question regarding my solution, any steps, the concepts I am applying, if you do not understand any concepts, or if you have any doubt or question in my solving, please feel free to let me know in the comment section. I will highly appreciate that. And if you have in general any doubt, any question on any concept from the chapter, then also let me know. I will do my best to help you out. Let's see the next problem. The radii of two RCCs. RCC means whenever I will say RCC, it means right circular cylinder. The radii of two RCC are in the ratio 2:3 and their heights are in the ratio 5:3. The ratio of their curved surface area is, okay, so let's say RCC, for the RCC 1, let's say RCC 2. Based on the ratio, I am considering the radius, base radius of the RCC1 R1 to be equal to 2x. Since the ratio is 2:3, I am considering the radius of the RCC1 as 2x. So therefore, the radius of the RCC2 will be 3x. Also, I am considering, I am assuming the height h1 of the first RCC to be 5y based on the ratio 5:3. So the height h2 of the second RCC will be 3y. So now we have to find the ratio of the curved surface area. Curved surface area means the ratio curved surface area of a RCC means the lateral surface area. So LSA 1 will be equal to, we know it is 2 pi RH, which will be 2 pi 2x multiplied by 5y, which will be 4. Now this is 2 pi into 10xy. What will be the lateral surface area of the second RCC? It will be 2 pi R1 H1. Sorry, this will be R1 H1 and this is R2 H2. This is 2 pi, R2 is 3x and H2 is 3y. This is equal to 2 pi into 9xy. So this implies LSA1 by LSA2, the ratio of the lateral surface area or the curved surface area will be 2 pi multiplied by 10xy divided by 2 pi multiplied by 9xy. So this is equal to, if you simplify, this will be 10 by 9, which is, so the ratio is 10:9. Okay, let's see the next problem. A rectangular tin sheet of dimension 12 cm by 5 cm is rolled along its length to form a RCC by making the opposite edges touch each other. So basically, when you roll a rectangular sheet along any side, it could be along the breadth or it could be along the length, a RCC is formed. Now the concept is that you must know, if you are given, if it is said that a rectangular sheet of some dimension, length and breadth is rolled, then it must be known along which side it is rolled. Is it length or along the length or along the breadth? Accordingly, the RCC formed will be different. Its structure will be different. It is given in this whichever side. So let's say this is the rectangular sheet, and this is with what is wrong? Okay. So let's say this is the width, breadth, and this is the length. If this sheet, rectangular sheet, is rolled along the length, then the RCC formed, if the then what will happen is the radius, first of all the height of the RCC will be the width of the sheet. So if a rectangular sheet is rolled along the length, which is y, then the RCC formed, its height will be x, and the radius, if it is r, it will be equal to, so 2 pi r must be equal to y, which means r will be y by 2 pi. Similarly, this is the concept. Similarly, if so let's say the same rectangular sheet y of length y and x, breadth or width x, if it is rolled along the width or breadth, then the RCC formed, its height will be y, and the radius r will be equal to x by 2 pi. So this one concept you must be very well aware of. In this problem, a rectangular sheet is rolled along its length. Okay, so we must have r, the radius of the RCC formed, the base radius of the RCC formed will be equal to, since it is rolled along the length, it should be the length divided by 2 pi, which is 12 divided by 2 pi, and height should be equal to the width or breadth of the rectangular sheet, which is 5. So we know r, we know h of the RCC, we can easily find the volume. So volume is pi r square h, which is pi, r is 12 by 2 pi is basically 6 by pi square, and h is 5. This is equal to 36 pi 5 multiplied by pi square. So this is equal to 36 multiplied by 5 is 180 by pi. So the volume of the cylinder formed when the rectangular sheet is rolled along the length is 180 by pi centimeter cube. Okay, let's see the next problem. Question number 4. If the area of the curved surface and the circumference of the base of a RCC are the values are given, then the volume of the RCC is, the area of the curved surface means the LSA, the lateral surface area. LSA we know is 2 pi RH, where r is the base radius and h is the height of the RCC. Always remember that the curved surface means the lateral surface area. Okay. This is given as 4400. What is the circumference of the base? Circumference of the base is 2 pi r. This is given as 110. So then we can say, putting the value of 2 pi r as 110 in this equation, we will have 110 multiplied by h is equal to 4400. So this implies h is equal to 40. H is equal to 40 centimeter. The question is asked to find the volume of the RCC. So volume is pi r square h. Now we do not know, okay, from 2 pi r equals to 110, we can know find r as 110 by 2 pi. So the volume is pi r square. What is r? R is 110 by 2 pi square multiplied by h is 40. So this is equal to, let's cancel out and simplify 110 by 2. Okay, so this will be 55. So this becomes 55 square multiplied by 40 divided by pi. 2 pi r is 110. So 110 multiplied by h is 4400. Fine. 40. H is 40. 22 by 7. Okay. Let's see. So this is 55. 55 multiplied by 55 multiplied by 40 divided by 22 by 7, which is equal to 55 multiplied by 55 multiplied by 40 multiplied by 7 divided by 22. 11 to 11, 5, 2 to 20. So 100. So basically this will be 38. It should be 38500 centimeter cube. Okay. Let's see the next problem, the last problem. Two rectangular sheets of paper, each 3 centimeter by 18 centimeter, are made into two RCCs, one by rolling the paper along its length and the other along the breadth. The ratio of the volumes of the two RCCs is, okay. So let's say, okay, let's say that both the rectangular sheets are of same dimension. Instead of using the absolute values, that is the actual values 30 by 18, let's say the rectangular sheet is of dimension y by x. So when this sheet is rolled along length, the RCC formed along length, the height will be equal to x, and the base radius will be equal to y by 2 pi. Okay, y by 2 pi. Okay. Now when the same rectangular sheet x by y is rolled along breadth, the RCC formed, its height will be y, and the base radius will be x by 2 pi. So now let's say V1 is the volume of the RCC formed when the rectangular sheet is rolled along the length. So pi r square h, r is y by 2 pi square, h is x, and let's say V2 is the volume of the RCC formed when the rectangular sheet is rolled along the breadth. So pi r square h, r is x by 2 pi and h is y. So this is equal to y square x by 4 pi, and V2 is equal to y x square by 4 pi. So then what is V1 by V2? V1 by V2 will be equal to y square x by 4 pi, this divided by y x square by 4 pi. If you simplify this, it will be y by x. So simple. So this is equal to y was the length, length by, so it is basically length by breadth, 30 by 18, which is equal to 15 by 9. 15 is to 9 is the ratio of the volume O. So we can further simplify this. This is equal to 5 is to 3. So I hope solving these problems will give you a good idea of how we are applying the concepts of surface areas and volumes of a right circular cylinder to solve real life practical problems. If this video was beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Probably I will make another 2 videos in solving the conceptual problems from the textbook of author R.D. Sharma. So please stay tuned for the upcoming videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.